Now let's take our code that we wrote in the previous video and write it in a more idiomatic fashion. So by idiomatic, I mean in a way that you would probably encounter it in the real world, so to speak, whatever that means. So what we're going to do is we're going to build this code from the ground up. Okay? So let's first just return the empty string, and let's see what tests pass and which ones don't. So the first one that fails is when the sensor string is empty, in which case we just return the input string. So let's handle those cases separately. So we'll do exactly what we did before. We'll just say if s is empty, we'll return the empty string. If the sensor string is empty, we'll return s. And then otherwise we'll do some work. So what work do we do? Well, we're going to create a string which is the censored string, is what we're going to be building. And then we're going to do some stuff, and then we're going to return the string. Okay? So again, this is what I showed you in the video before last, where we create the thing we're going to use, we use it a little bit, we do something, and then we return it. Okay? So what are we going to do inside of here? Well, we need to check every single character in the string. So we had better have a loop of some kind that goes over every character in the string. So the most idiomatic way to do that is to start our loop off at I equals 0, and then loop as long as I is less than the length of the string. Okay, sorry, wrong thing. So as long as I is within the bounds of the valid indices of a string, then we'll keep looping. Okay. Now, what we want to do is we want to check every so often whether the string starts with the target string that we're looking for. Now you may think, well, wouldn't it always start with the same thing? The answer is yes, but there's a method that we can use that really helps us out in this case. So, if you recall, maybe, I don't think I've ever showed it off, but in Java there's a method called starts with. Okay, and as the name kind of implies, it returns true so let's say we have the string s, if s dot starts with t, so literally if the string s starts with t, if the first characters of s are t, it returns true, otherwise it returns false. So for example, hello dot starts with the string he, that returns true. If it were hello, it would return true. If it were the empty string, it would return true. But if it were hey, it would return false. If it were any other letter besides h, it would return false. Okay, so very simple. But much like many methods in Java, this method is overloaded, and what that means is there's another version of it. Remember how there's another version of substring that lets you put in just one parameter or one argument? Well, there's a version of starts with that lets you put in 2. And what it does is it allows you to pass an index. Okay? It allows you to pass an index, and that index will say, we're going to look in S, starting at index, to see if that substring starts with T. Okay? So for example, if I did the string 1, 2, x, y, 3, 4, dot, and then I'll write it in a slightly different font, or different color, starts with, and then I did x, y, and I pass it 2, this would return true. Because if we just consider the string if we just consider this string, then yes, that substring does start with xy. Okay? So this is a case analysis yet again, just like everything in life. So the case analysis is if s with respect to index I starts with t, then we want to append the length of t copies of our replacement character c. Now we've kind of already done this, right? We did that with dot repeat. So that's not really a problem. What about the other case where it doesn't start with it? Otherwise, we'll just do like what we did in the standard recursive version, where, well, actually we do this in all of them, where we just take the ith character, right? Well, with all the other versions, we just use substring, but if you did the little bonus exercise that I gave, where I said, instead of using substring, use indices, if you do that, then you'll see that we can just use the ith character and append that instead. So, otherwise, append, let me put it in both places, append, and whenever I say append, I also, in the context of strings, I mean concatenate, append s.char at I to the result string, to the accumulator. Okay? So, let's just type that in. So, if s.starts with, we're going to give it sensor string with respect to I. If it starts with sensor string with respect to I, then we're going to say acc plus equals, remember plus equals, we're going to do string.value of replace.repeat sensor string.length. Okay? And now there's one more thing we're going to need to do, but we'll come back to that. Otherwise, we'll do acc plus equals s.char at index I. Okay? So right now, let's just run this and just see what happens. Okay? So here we have a little bit of an issue. So we have expects plus plus, but we gave it, or it produced plus plus y. And the problem is that we are doing something a little bit, we're not being very careful about what we're doing. So, if we find the string, like let's say we have 1, 2, x, y, 3, 4 for the 20th time, our search string is x, y. If we find the string, if we find this in here, then we want to jump over, so for example, if we find on index 2 the string xy, then we don't want to consider this string, or rather we don't want to consider this character. So we want to jump from here to here. Okay? So the way to do that would, of course, you may think, okay, we'll just take the index that we care about, which is, or the index that we're using, I, and then just increment or just add to it the length of t, right? Because that would get us from index 2 to index 4. Okay, let's try that. Let's see what happens. I plus equals the length of the sensor string. Seems fairly innocent. But now there's a problem. So this test doesn't pass. So why doesn't this pass? The problem is that we skip over a character. So when we're modifying I, which really isn't the best idea, if you're modifying the variable that is being changed with every loop, you have to be very, very careful. In this case, we're not being careful. The problem is that when we have this I++, remember, that still is going to happen. That plus plus operation doesn't go away because we modify I. So inside of our thing here, we say that I becomes 4, but then I becomes 5 because of that plus plus. Okay? So we completely skip over the 3. That's not good. So instead of doing I plus equals the length of t, we need to do I plus equals the length of t minus 1. Because if we do that, we'll go here, and then the plus plus operation will take us to the correct index. Okay, so do that minus 1, and now all tests should pass, and they do. Okay, so this is very idiomatic Java code. So this is something that you'd probably see, well, It's something that you might not see in the real world because you're usually not writing methods that are this simple, but this is more in line with actual Java real world code, again, whatever that means. And really, that means that the code that we're going to be writing for the rest of the, or in the rest of the class, in the rest of the book, is going to look like this. Okay? We're not going to use while loops when we don't need to. We're going to use for loops whenever we're traversing over a data structure, such as a string. Okay?